Okay, finally got it for you. But I wanted to make sure that I gave you a video in addition to the picture that I gave you, because the picture is just going to be crazy. So I got a couple things for you here. I'm going to try to do this as best and as efficiently as I can. Here is the sixth degree polynomial. And this is one of the roots, but you know if this is a root, the conjugate of that also is a root. So it would be 4 minus 3i. Now, what we need to do is we need to write these two roots, or these two zeros, as an equation, okay? And we need to basically set it up as a quadratic, just for these two, because that's the only way that you're going to efficiently be able to get the other 4 roots, because you know this is a sixth degree polynomial, that this is going to break down into 6 different roots. 6, right? 6, okay. So to do this, and it's on the paper that I sent you, so I'm working off of this. 4 plus 3i is x minus the quantity of 4 plus 3i. Okay, so it's basically, this is one of the factors. This is one of the equations that I set up. And the reason we do this is because, remember, whatever this is, x has to equal the opposite of that, so it would be 0. So this would be the one 4 minus 3i, or 4 plus 3i. Then the other equation is x minus, because the x minus has to happen, and yes, there has to be 2 sets of parentheses here. So this is 4 minus 3i. Okay, so I'm going to set that up. First, I'll simplify this so we don't have 2 sets of parentheses, and then I'm going to FOIL it out. But I'm going to just go straight up with it. Ask me a question later if you have an answer, a question for that. So this is going to be x minus 4 minus 3i times the quantity x minus 4 plus 3i. Just so you understand how I go from one level to the next. I need to FOIL these two things out. When I do that, okay, so just be careful about your pluses and minuses, because that's something that got me tripped up yesterday. When you do that, you're going to get the quadratic x squared minus 8x plus 25. Now, this is something that we can work with a lot easier. And this was one of the things that I struggle with, because how do I find the complex roots of a function? Because I can't see them on a graph, and I can't put I into any equation. Like, I can't use synthetic division, and I can't use the rational root test, because that's not rational, right? Anyway, this is what I get from the original. Now that I have this, I'm going to use long division. Remember, synthetic division works if I have x minus 1 or x plus 1, because I can only put 1 in the box and then work it out. Because that's a square, this is a quadratic, I can't do that. What I'm going to do is I'm going to set up the long division problem. So x squared minus 8x plus 25 is going to divide into this long thing. And yes, I'm going to write it. X blah, 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 right? So a whole bunch of stuff here. Oh, that's a 4. 4 minus 40x to the 3 plus 1, 19x to the 2. I'm not going to work this whole thing out because that would take forever. But you get the idea. Hopefully you can see that. Okay, I'm dividing this into that. When I do that, and the work is on the paper or the picture that I sent you, when I do that, there is a remainder of 0, which is exactly what it should be. And I get in the top here, so this is going to be x to the 4th, so I'm going to get a quartic polynomial here, plus 5x squared minus 6. Now, this is the thing that we were looking for, okay? This is what's left over after I get these 2 factors out. So from here, because this is to the 4th power, I can get 4 roots from this. This is actually very manageable to factor. Okay, to do that, I know that, see, this is the thing that you may not like so much, because I'm old school with the whole, oh, I can find the factor by the 2 multiples of the factors of 6, and they have to add to be 5. This is what I did. I know that it has to be x squared, and I know that it has to be an x squared there. Now I know that I have to find factors of negative 6 that will add to give me 5. So I know one has to be 6 and the other has to be 1, because 6 minus 1 will give me 5. So this has to be a plus and this has to be a minus. I'm going to set both of these equal to 0. Okay, so I'm going to erase the top part so we can get a little bit easier here. This is crazy problem, but it actually isn't that bad. Okay. When I factor this out, I get these two. So it's going to be x squared plus 6 equals 0, and x squared minus 1 equals 0. This is the easier one, right? Because it's x squared equals 1, because I add 1 to both sides. So if I square root both of these, I get x equals plus or minus 1. That's where the 1s come from. So remember how I said when we met that this was going to be something you could use a guess and check with the rational root theorem or the rational root test? You don't even have to do that. long divided, which is the longest part of this, but then it gives you the 4 roots really nice and easy, okay? So on this side, I get these two. Here, I get x squared equals -6. This is something that you should know from your radicals and your exponents from the previous couple units you did. When I square both sides, I get x equals plus or minus -√6, or root -6. This is getting broken down. This is the square root of 6 times the square root of -1, which you already know is going to be √6 times I. That's where the other two factors come from. The other two factors are x equals plus or minus I √6, which is exactly what your answer sheet says. Now I have my 6 roots. 1, 2, 3, 4, and the 4 plus 3i, 4 minus 3i. Those are my 6 roots, and I can definitely get this a little bit better. That took a long time. It took 6 minutes to explain, but the long division is the hardest part, and then you can work it out that way. Now, there's a way that you can do this on your calculator. The only downfall with using the calculator, number one, please make sure you can use it. Like, please make sure that you can use this program on your calculator. You have the same calculator as I do, but make sure this is allowed, because some teachers don't allow this. I don't know why she wouldn't let you do this, but just make sure you can do it for sure, because I don't know if it's called cheating or not. Anyway, I'm off that. And the other downfall is it will not provide you the radical sign. It will be a square root here, like an actual decimal. So you're going to have to guess and check on what the actual radical is. Now, it doesn't provide you with any of the work, but it does give you at least a starting point if you're totally lost on a problem. So use this if you need to, but if not, don't worry about it. So I'm going to try to remember the process, and we'll go from here. On your calculator, on your TI-84, because you have the same thing I do, you're going to hit the button called Apps. Okay, and mine's in purple, and it's right underneath the X button. It's called Apps. Okay. Now, there's a whole bunch of things here. What I want to do is I need to scroll down to where the P's start. So to do that, I'm going to hit alpha, the green button, and I'm going to go to P, and P is actually the 8. Okay. Now, I want to find Poly Simulator 2. It's Polynomial Simulator. It's going to give us exactly what we need. I'm going to hit Enter. And it's going to give me this Texas Instruments, here's my app screen, whatever. Just hit Enter again. Now, you're going to go to the first function. It's Poly Root Finder. Okay, this is going to give you exactly what you need. It's really, really cool. I just figured this out. So you're going to hit Enter on number 1. Now, there's a whole bunch of stuff here. On the top, it says what order. So you can see that I'm on order 6 because I did this before. So just you would scroll over with the keypad. You want the 6th degree polynomial. And you definitely want A plus BI because you want to be able to use complex number system, right? This is not going to work. You want that. Decimal version, what is this? Normal, float, degree, all the rest of them are the same. Now, next is actually this button here, graph. So you can hit graph. Now, it's going to ask you for all of the coefficients. So for the 6th coefficient, I put in 1 because, again, that's the coefficient for the x value. Then you can see it's 8, 30, -40, 119, 48, and the last one down. Make sure you fill them all out. The last one down is 150. Okay. Now there's a button that says solve, so I'm going to hit solve, but solve is this button here. It's going to take a minute because this is a 6th degree polynomial. It's a serious deal. This is serious. Serious. Here we go. It's giving me all of my roots. So x1 is 4 plus 3i, x2 is 4 minus 3i. It will give you the complex number, but it won't give you a radical sign. Let's skip down to x5 and x6, which you already knew is -1 and 1 because of what your answer key says. Now here's where it's tricky. The 3rd and 4th root value is 2.442. You need to be able to guess and check to identify that that's the square root of 6. Now, at the very end it says I. Okay, so it's root 6, or it's I root 6, but it just takes it out of order. Now, the second one, you don't see the I because you just have to get down a little further. You would go over. So it's the same thing because it's too long, but it's also I root 6. Okay, so please make sure you know how to do that. This is a lifesaver, this program, and I don't know why I didn't know it before. I had to go on the internet to find out how to do that, but those steps are there. If you need me to do the steps again for you, we can do that. Again, this problem, the long division is the longest part. It's the hardest part of that, but once you get the long division done, it will always have a remainder of 0, so you shouldn't have an issue. Okay, Still trying to figure out the process with your graphing calculator, why it's a little bit off, but it has something to do with the viewing screen, obviously. I'll see if I can get that to you by tomorrow. If not, do the best you can. That polynomial root finder is going to be legit. Let me know if this helps. If it's a little unclear, we'll work it out, all right? Good luck. See you later.